Hello.
Hello, ma'am. Good morning, ma'am.
Good morning, ma'am. Am I audible?
Yeah, ma'am. You're audible,
Okay.
ma'am.
Okay. So let's start today's class. Okay. Today I will start from atomic structures. My screen is visible now. Screen is visible.
Yes, ma'am.
Okay. Okay. So let's start with atomic structures. Okay. I think all of you know what is atom now. All this material, actually these are made with all the materials like books, all these materials are made with some molecules. These molecules is again made up with atoms. So today we'll start the structures of these atoms, what how these atoms are consist of, and all these things. Okay. So first of all, we have to know the history of the atoms. Uh, in 1460 BC, there was a scientist whose name was Democritus. First of all, he developed the ideas of an atom. After Dalton, after Democritus, there was one more scientist, John Dalton. In 1808 centuries, this scientist, John Dalton, he suggested that all the matters was made up of tiny spheres that were able to bounce around with perfectly elastic, and he called them as atoms. Okay, so first, who gave the idea of these atoms? It was Democritus, and after Democritus, it was John Dalton who proposed the idea that this atom is made up of some tiny spheres. After John Dalton, in 1898, there was a scientist whose name was Joseph John Thomson. What he did, he modified the Dalton's atomic model, and he found that the atoms could sometimes eject a far smaller negative particles, and later he named these negative particles as electrons. This Thomson, he developed an idea that the atom is made up of electrons, and these electrons are scattered unevenly. These electrons, those are these electrons are scattered unevenly within an elastic spheres, and this elastic sphere is surrounded by a group of positive charges, and these positive charges balance the electron charge. That is why the atom as a whole is a neutral particle, because in this atom there are equal numbers of positive and negative charges, and this model of atom, it is known as plum pudding model. After Joseph John Thomson, one more scientist in 1910. His name was Ernest Rutherford. He's modified this Thomson's atomic model, who said that these electrons are inside these atoms. Where he modified this atomic model, and for that he carried out an experiment. It was a famous experiment. This is this alpha particle scattering experiment. In the experiment, here he has taken a gold foil here, and he has allowed some of the alpha particles to fall on this gold foil. And after that, after the falling of the alpha particle, okay, you know what is alpha particles? Actually, these alpha particles are nothing. These are doubly charged helium nucleus atoms. When this alpha particles falls on this gold foil, some of the alpha, he has observed that some of the alpha particles will fall on this gold foil, and they will scatter without any deviation, and some alpha particles will deviate from its original path, and some alpha particles will return back to this origin, hence it will bounce back with a 180-degree. In order to observe this scattering of the alpha particles, he used a detector here. After this experiment, Rutherford found that most of the helium nuclei passed through this foil. Small numbers were deflected, and to their surprise, some helium nuclei bounced straight back. So these are the three basic findings from this Rutherford's alpha particle scattering experiment. The first one is that most of the helium nuclei passed through the foil. Second one is small numbers were deflected, and the third one is some helium nuclei bounced straight back. So based on these assumptions, he proposed an atomic model of an atom. Okay, these evidences allow him to propose a more detailed model. First of all, this Thomson's proposed a model, but it was not that much in detail. He suggested that this positive charges was all in a central nucleus. And these electrons were these positive charges resides inside the nucleus, and these electrons will revolve around the nucleus. After Rutherford, Niels Bohr modifies the atom. He proposed that Niels Bohr in 1913 studied. He was a student of Rutherford. He refined Rutherford's idea, and by adding that the electrons were in the orbit, rather like planets orbit the sun, with each orbit only what if and each orbit will permit only a certain numbers of electrons. It will depend, suppose in the second orbit will permit only 2 electrons, the third orbit will permit maximum, but there is a maximum number of electrons that third orbit will permit, similarly like fourth, fifth, and like that orbits. Okay, this is the Bohr's model. According to this model, this is the nucleus. Here, protons, which are positively charged particles, they will reside inside this nucleus, and all the electrons, which are negatively charged particles, they will revolve around the nucleus like this way. These are the electrons. They will revolve around the nucleus in some definite path, and these are known as electrons orbit. These are the positive charges, and inside an atom, this atom is as a whole is neutral. Why? Because here these protons, they are positively charged, and these electrons, they are negatively charged particles, but as a whole the electron is neutral, because here this numbers of positively charged particles, they will be equal to the number of negatively charged particles. That is why these atoms will behave as a neutral particle. This is a helium atom. Here in helium atom, I have already told you that in any atoms, this number of positive charge will be equal to the number of negative charge. This is a helium atom. It has 2 protons. These protons will reside inside the nucleus. So these are the protons. 1, 2 protons. And this electrons, the 2 electrons, since here it has 2 protons, so it must have 2 electrons. These electrons, this is 1 electron and this is second electrons. These 2 electrons, they will revolve around this nucleus in some well-defined orbits. This orbit, this is the first orbit, it can accommodate maximum 2 numbers of electrons. Okay, inside the nucleus, instead of protons, there is one more particles, that is neutron. These neutrons, they are actually neutral particles. Okay. So the atoms, actually what the atom is consist of, atoms is basically consist of 3 particles. One is proton, electrons, and neutrons. Protons, these are positively charged particles. Neutrons, they are neutral particles. They will reside inside the nucleus. And the electrons, they are negatively charged particles. They will revolve around the orbit in some well-defined path. This path are called, this is called orbit. Okay. These are the particles that consist of an atom. Okay, all this I have already told you. All the materials, they are consist of 3 particles. One is proton, neutron, electron. Okay, this proton, it has a positive charge. Neutron, it is no charge, or you can say that it is a neutral particle. Electrons, it has some negative charges. Okay. Actually, an atom is represented like this way. Since I have considered a helium atom, so helium atom is basically represented as He. Okay, this is two. This is called the total number of protons in an atom. Since this helium nucleus, it has two protons, it is written as 2. If we have considered some other elements like hydrogen, not hydrogen, lithium, which has 3 protons. So you have to write it here 3. And this is the symbol of lithium is Li. This is we have considered helium nucleus, so I have written the symbol of helium is He. It has 2 protons, so it is there written here like this way. And this is for what is this called? This is called atomic mass number. What is mass number? This is the total number of protons and neutrons in an atom. Here, this atomic number, this is the number of protons, which is equal to the number of electrons. Since helium has 2 protons, so it must have 2 electrons. Otherwise, it will have some electrical charge. But in nature, we haven't found any charged atoms generally. Okay, these electrons, they are arranged in some energy levels. In helium atoms, we have only 2 electrons, so one orbit is sufficient, or one energy level is sufficient. If an atom has more than 2 electrons, then where these other electrons will go? They will go to the next energy levels. That means this is called the first shell. If this first shell will completely completed, then these electrons will go to the second cell and then third cell and so on. In the first shell, it can have a maximum of 2 electrons. The second shell can have a maximum of 8 electrons. And third shell, it can have a maximum of 8 electrons. Okay, next thing is that how we can represent these atomic structures. There are 2 ways to represent the atomic structures of an element or compound. One is electronic configuration, another is dot or cross configuration. Okay, let's first see the electronic configuration. In electronic configuration, these elements are represented numerically by the number of electrons in their shells and number of shells. Okay, let's take one example. So we have already taken helium, which has 2 electrons. Let's take another example. Let's take the nitrogen atom, which has its atomic number is 7. That means it has 7 electrons, or 7 electrons and 7 protons. And I have already told you that in the first shell can accommodate a maximum of 2 electrons. Then the remaining 5 electrons, where it will go? It will go to the second orbit. So in case of nitrogen atom, 2 will be in the first shell and the 5 will be in the second shell. Okay, I have an assignment for you. Write the electronic configuration of these following elements. Well, this is calcium. It has atomic number 20. That means this element has 20 protons. Since it has 20 protons, so number of electrons will also be 20. The sodium, it has 11 protons. Oxygen, it has 8 protons. And like this. And this is the electronic configuration. There is one more configuration, that is dot and cross configuration. Okay, after that, you will get the term that is isotope. What is isotopes? Isotope is nothing. These are the atoms that have same numbers of protons but different numbers of neutrons. Okay, this is an examples of isotope. This is the isotopes of hydrogen atom. It has one proton. This is one proton, one neutron. And it has one proton and two neutrons. That means all these three atoms, these isotopes of hydrogens, all have same numbers of protons. All of them has one proton, but the neutron number is different. That is why the mass number is different. It has no neutron here, one neutron, and here it has two neutrons. So in a summary, what we can say that what is atomic number? Atomic number is nothing, it's just the number of protons in the nucleus. So for hydrogen, since it has one protons, so its atomic number is 1. For helium, since it has two protons, so its atomic number is 2. Like lithium, it has 3 protons, so its atomic number will be 3. Next term that you have to remember is that atomic mass. What is an atomic mass or mass number? It is the number of protons and neutrons. That means total number of protons and neutrons. These are together called as nucleons. So atomic, what is atom? Often the atomic mass of an atom is the total number of nucleons. In case of hydrogen, 1 proton and no neutron, so its atomic mass is 1. Similarly, for helium, it has 2 protons and 2 neutrons, so its atomic mass is 4. And inside an atom, since this atom as a whole electrically neutral, so since electrically neutral and these protons are positively charged and these electrons are negatively charged. So in order to make the atoms electrically neutral, the total number of protons, it must be equal to the total number of nucleons. These atoms are consist of 3 particles. One is proton, electrons, and neutrons. These protons and neutrons, protons which is positively charged, and the neutrons which is negative neutral particles, they will reside inside the nucleus, and the electrons which are negatively charged particles, they will orbit the nucleus. And each orbit, and this well-defined part, or you can say this orbit, each orbit can carry a definite number of electrons. The first orbit can carry a maximum number of 2 electrons, and the second shell, it can have a maximum number of 8 electrons, and a third shell, it can have a maximum numbers of 18 electrons. So these are the summary of today's class. Okay. If you need, I can share the class notes and please give me your attendance in the. Please write your roll numbers in the chat box.